won't go over the answers. That's why I made you turn it in yesterday to see how far you got. So everyone got points as long as that's all you did some sort of math, whether it's right or wrong. That's up to you to fix. What was I going to say? I don't even know. I'm not having a great day. Yesterday was not a great day. Tomorrow's not going to be a great day, but it's going to be okay. So I'm sorry I'm in a bad mood. I'm working on it. I'm trying. Let's talk about Tuesday's bell ringer. Yes, we got to go that far back. I'm going to talk about Tuesday, Wednesday, Thursday, and even something from Friday. We're going to go bell ringer crazy. So on Tuesday's bell ringer, it says that we had a line 3x plus 4. I'm just going to pretend it's there. That looks about right. And then it says, which of the following describes the transformation of the line parallel to it with a y-intercept of negative 3? So this one would be y equals 3x minus 3. Okay, how did I go from this line to this line? Did I translate? Did I rotate? Did I reflect? I reflected? It looks like you just shifted it. We shifted it down, so that would be, what vocab term is that? Translate. So it's either got to be C or D. And then did we go down 3 units? How far down did we go? 7, because we went 4 from here to 0, and then 3 more down, so a total of 7. So our answer should be D. Okay, make me happy and someone tell me you factored yesterday and what your 2 factors were. 2 times 1 is just 2, though. It's got to be 3 and negative 1. So 3 plus a negative 1 gives me a positive 2. 3 times a negative 1 gives me a negative 3. I think she's right. So I'm going to do x plus 3 and x minus 1. So if you were to see this on a standardized test and they gave you some multiple choice answers, would you pick 3, negative 1 as an answer? Or would you pick negative 3, 1 as the answer? The answer would be B. And if you're still not sure why that is, we set each of them equal to 0. So x plus 3 equal to 0, and you get x equals negative 3. X minus 1 equal to 0, and you end up getting x equals 1. That's why we're saying it's B. But if you realize that like Danny did before I wrote that part, that's great. Okay, everyone in the room has a test tomorrow, so everyone in the room knows how to do this next problem. What do I need to use to solve for x? What formula? Be brave. Of course, Pythagorean theorem. What needs to be the C? Always across from that hypotenuse. So I have 12 squared plus x squared equals 25.5 squared. I know 25 squared is 144. So 144 plus x squared equals, I don't know what that is. What was 25.5 squared? Okay, and then, no offense, but why are you frantically writing? Because you had bell ringers yesterday. I wasn't here to do math, but you sure were. And this was the darn Pythagorean theorem. So why didn't you do the darn Pythagorean theorem without me? So many questions. Please tell me a number. Whoa. That does not feel right.
What was it?
0.25? Okay, and then if you subtract 144, what do you get?
5.
And then when you take the square root of that, what do you get? Which is A. I have graded all of first period and most second period Pythagorean theorem projects, which brings me to there are 5 people in this room who I'm not turning in. One of those people was, 2 of those 5 were super absent. The other 3 have not been. As of today, you would be at a 40 out of 60, which is better than the 0 I'm going to type in this afternoon, because I haven't typed it in yet. So you thought your grade was low, it's not low, until I type in that 0 in the 60% category. Why have you not turned in my project? This problem reminds me of the project because there's at least one person in the room who stops every time right here. they don't take the square root and get what x equals. They're not finishing the Pythagorean theorem. They're not getting all their points on the project, and they won't get all their points on the test. Okay, flip to the back. I heard Trey reading this one out loud. I don't really know why. Every time you see a ladder problem, it's going to be the Pythagorean theorem. There's a ladder. I've got my house. It says my window's 25 feet above, and that there are some bushes and stuff on the ground, so it has to be 10 feet out from the wall. So really, I have a right triangle with two legs, 10 and 25, and I'm solving for the length of that hypotenuse. If you didn't already do 10 squared plus 25 squared equals x squared and solve for x, then that's what you need to do for homework, because I'm telling you, I'm picking this one for the next bell ringer test. And you need to have more than just what I wrote in order to get the points out of me. You need to have solved using the Pythagorean theorem. Okay, I know today is Thursday, so you haven't even looked at Fridays. I know that tomorrow you have a test, so you were just going to skip Fridays entirely anyway. But there is a really good question I want to look at, and no, it's not factoring. I want to look at number 2. This really shows me whether or not you're ready for the test tomorrow if you can answer this question. So it says if triangle ABC is a 30, 60, 90 right triangle, which of the following sets could represent triangle ABC's side lengths? Why is it not A? Okay, all the others have something with a radical. That is true, but why is it not A? 2, 2, 2. What kind of triangle is that? Which makes it equiangular, which makes it a 60, 60, 60, so it's no way it's 30, 60, 90. Why is it not B or C? And why can't it have the square root of 2? What is the square root of 2? Can it go with? Okay. That's a good notice. That's good. That's good. So if you had to guess from there, what answer choice would you pick then? It is E. But there's another reason I can eliminate B and C. Why is that? What kind of triangle is B and C? Look at the options. Yes, it is isosceles, because 2 of them match, which means it's what kind of triangle, if we're doing rights. So B and C are both 45, 45, 90s, but Elena's right. Just noticing that pattern of we're looking for a square root of 3, not a square root of 2, that eliminates everybody except E. Since it is E, tell me what is the 2? What part of the triangle? It's the short leg. What's the 4? Hypotenuse, because we doubled it, and then since we multiplied by the square root of 3, this is the long leg. If you noticed all that, then I would say you're ready. If you didn't, oh, you need to study. Okay, I know you did this, and we can go over some of the answers quickly. I don't know if yours are right or not. I would make sure they're right, except for my test tomorrow. Only test tomorrow, since I am not here. And let me say these words. No, I'll save those words for later. Let's just go over the answers, and then I'll say my words. Nick, have those blue sheets ready to hand to me in a second. Okay, yes, both of them. What do we need to use on number 1, 2, and 3? We are using the converse Pythagorean theorem. So if you're confused on 1, 2, and 3, we're supposed to use the converse Pythagorean theorem. If I use the equal to sign, it's right. Does the less than sign go with acute or obtuse? Obtuse is the opposite of what you think. Okay, so you solved on number 1, and what did you pick as your answer? Acute. You did 6 squared plus 8 squared, and then you had 9 squared. So you had 36 plus 64, which was 100, and that is greater than 81. Since you chose the greater than sign, you said this whole thing was an acute triangle. Okay, what did you pick on number 2? How did you know it was a right triangle? Which triple? It is a multiple of 5, 12, 13 times 2 times 2 times 2. If you don't recognize your triples still, you could always use Pythagorean theorem. 10 squared plus 24 squared, 26 squared. You would end up picking the equal to sign. If you're not confident with your triples like Toby is, then I highly recommend using the Pythagorean theorem. Figure it out. Okay, and then what'd you get on number 3? 16 squared plus 18 squared, and then you also had a 24 squared. What was 16 squared? 256. What was 18 squared? 524? 324. 324. And then what was 24 squared? 576. Okay, and then 324 and 256 added together to give you what? 580. So 580 is greater than 576. Agreed. And since you picked the greater than sign, you said it was an acute triangle. Again, we said this one was a right triangle. I don't know why I didn't write it. Okay, I had someone last period who they meant well. They genuinely did. On number 1, their answer was no. On number 2, their answer was yes. On number 3, the answer was no. Did they follow the directions? No. Or are they going to get all their points out of me? No. Do they know what they're doing? Yeah, they used Pythagorean theorem. But they did not follow the directions, and they're missing out on points. There's no need to miss any Pythagorean theorem questions. So if you missed anything like 1 through 6 on the test, especially my second period class, I'd be so mad. Okay, so 4, 5, and 6 are just straight up Pythagorean theorem. What did you get on number 4? 12. How did you get 12? 7. How did you get 12? So you did 9 squared plus x squared equals 15 squared. That will always work, but it is a triple. What triple is it? It is a 3, 4, 5. So I knew it was 12 because it's a triple. If you recognize something as a triple, what can you put on the test so you don't have to show me anything? Triple, PT, something so I know you're alive. Anything. Okay, you won't believe this, but 5 is a triple too. Really? Yeah. You can do 25 squared plus x squared equals 65 squared. What did you end up getting when you did that? 60. So you got x equals 60. What's 25 divided by 5? 5. What's 65 divided by 5? 13. What's 60 divided by 5? It's a 5, 12, 13. Do you have to solve it that way? No. Is that convenient? Sure is. Okay, number 6 is silly because they draw the picture for you. Am I necessarily going to draw a picture for you? No. You've had the Pythagorean theorem project. You just did that ladder problem. My gosh. If there's anything like about a ladder or a ramp, it's always the hypotenuse. Please don't be blondes. Why, besides the fact they drew you a picture on number 6, why else is number 6 super duper easy? It's the same numbers as 5. So 5 was 25, 60, 65. 25, 60. Guess what? This one ends up being 65. If you didn't notice that, I'm sorry to burst your bubble. You could have done 60 squared plus 25 squared equals x squared. You still would have ended up with x equals 65. If you struggled on 1 through 6, you're breaking my heart because that's the Pythagorean theorem. That's the part we were going to rock. Do you realize how long it's been since we've had a test? That's how much time I've given up to make sure we had that thing down. You better nail it. You better do good on the Pythagorean theorem and the converse. I'm going to be mad. Okay, 7 through 12 is where we're actually possibly a little bit of trouble. Most people have these down, although I know some still are mad about it. What I would do first is find all the 45, 45, 90s. I would do all of those and then stop. And then all the 30, 60, 90s and stop. That way I wouldn't get them confused. So what problem should I start with? Okay, 7 sounds great. What did they give me on 7? The leg. Is it the short leg? No. Why not? They're the same legs. Okay, because it's 45, 45, 90. Okay. David's going to get some points out of me just for labeling the triangle, especially when it's a 30, 60, 90. This is not a 30, 60, 90. Okay, they gave me the leg. David's trying to get some points out of me. He's going to make sure he puts the same number on both legs. Okay, how do you get the hypotenuse when you're given the short leg? Okay, so short leg times square root of 2, so 8 times square root of 2, you end up getting 8 square roots of 2. So my hypotenuse is 8 square roots of 2. I know Sabdi, for instance, has this down. And if you took your checkpoint without your blue sheet, you have this down too. Do you have to show me all this work? No. Why might it be a good idea, though?
Because if you get it wrong.
Yeah, you'll still get some points. Trey's going to get some points just showing me which formula he picked, sadly enough. Sadly enough. So it wouldn't hurt to show work unless you're confident and you know I've been rocking it out and I'm not going to mess this up, Miss Compton. What problem should I do next?
8.
Okay, what did they give me on 8? Okay, so I don't know the legs. I do know the hypotenuse. How do you find the, or why did I put short leg? How do you find a leg when you're given the hypotenuse? Okay, and why is this one a nice problem? Okay, so we like this one because when we take our number and divide by the square root of 2, the square roots cancel out and we end up just getting 3 for the legs. Everything works out beautifully. We love number 8. What problem am I going to work next? Why do we not love number 12? If they give you a pretty number on the hypotenuse, you need to be scared because that's going to be a hard problem. So you're given the hypotenuse. You want to find the leg. You take your hypotenuse and you divide by the square root of 2. So 8 divided by the square root of 2. If Katie leaves her answer there, am I giving her her points?
Yes.
No. Not at all. What does she need to do? Okay, she can't have that radical in the denominator. How do we get rid of it? Okay, so what do I end up getting in the numerator? Okay, so Katie is the world's worst. No offense, Katie. At then saying my answer is 8 square roots of 2 over the square root of 2. Those cancel out. Is that the right thing to do?
Yeah.
No. Trey. What is the square root of 4?
2.
So it should just be 2, not square root of 2. Just 2, not square root of 2. She is the world's worst at that. You've got to watch it. Okay. And then what is 8 divided by 2?
4.
So my answer is just 4 square roots of 2. So the legs are both just 4 square roots of 2. I'm glad. Okay. Have I done all the 45, 45, 90s?
Yes.
Okay, which 30, 60, 90 should I do first? Why 9? Because, ha 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 ha. Thank you, Toby. Because they gave me the short leg. Why do I want to go with the ones where they gave me the short leg? They are easier to do. So we're going with 9, and the first thing I do on any of these problems is I label short leg, long leg, hypotenuse. Sydney's getting points out of me for labeling that. Okay, if you want to find the hypotenuse, you take your short leg, and what do you do?
Multiply by 2.
Okay, so I'm just going to knock you two out. I'm not that I don't love you both dearly. So it's 8 times 2, which is 16. I know Toby knew that off the top of his head anyway. He does not have to show me this work. He does not. You should, just in case, but he does not have to. Okay, for the long leg, how do you find the long leg? No, more Toby, you're out.
Multiply by square root.
No, I don't want to hear from you either.
Multiply by square root of 3.
No, that is your voice. I don't need it. I heard you. I'm going to pretend I just heard you. 8 times square roots of 3, and I just get 8 square roots of 3. Number 9's done. Okay, then we get to number 10. What did they give us on number 10? Okay, again, the hypotenuse is always across from that right angle. That's the hypotenuse. The one across from the 30 is the short leg. Here's my long leg. How do I go from the hypotenuse to the short leg? Okay, so to find the short leg, I take my hypotenuse and I divide by 2. So 30 divided by 2, what did you get for that short leg? Perfect. Good morning.
I'm gonna trade some furniture.
Awesome. Okay, and then, let's see.
That chair, I'm sorry to take it away from you. Do you prefer this one or this one?
Danny, pick a
This one's
chair.
more comfortable.
There you go.
Then I'm gonna put this one here. Sorry about that.
You're good. You too. Okay.
Y'all have a good morning.
We'll try. Okay, so we found the short leg. Do we know a way?
Math, right?
Yeah, exactly. If we know the hypotenuse, is there a way to go from hypotenuse to long leg? Trey said yes. David said possibly. Have we learned that magic trick? No. What do I always go for?
Short leg.
Once I find the short leg, do I know how to find the long leg?
Yes.
What do I do? Short leg times what?
Is there a way to go from there?
No. Like, I'm sure there for real is, but it's easiest to just keep on keeping on the way we've been doing it. This is always going to work.
Yeah, like I wasn't. I just did
If you're being real smart, it's always going to be that divided by 2 times square root of 3. So I already know it's 15 square roots of 3. 15 square roots of 3. So technically, yes.
Yeah.
For those of us like Katie who want to show a formula that we're plugging and chugging, no.
I did it wrong.
Why did you not multiply by the square root of 3?
I don't know.
Did you divide by the square root of 3? I don't know what you did to get the long leg. If you did square root of 2, would I count off a lot of points?
Yes.
Why?
Because that's a 45, 45.
Because that's a 45, 45, 90. Make sure the 3s are only with 30, 60, 90s, and the square root of 2s are only with 45, 45, 90s. Trey. Okay, and we're going to get set in just a second. Why is number 11 what looks to be the hardest one? Or were there any questions on 9 or 10? Okay, why does number 11 look to be the hardest one?
Because he got this.
You have a radical.
What part of the triangle did they give you? I always beware when they give me the long leg. Short leg's easy, let's face it, hypotenuse is easy. The only ones that are challenging are when they give me the long leg, but only if there's a pretty number on the long leg. Is that a pretty number? No, so magic's going to work out and life's going to be great. So to find the short leg, I'm going to take that long leg and divide by what? Okay, so when I do 9 square roots of 3 over the square root of 3, those cancel out, and I end up getting just 9. My short leg's 9, and my hypotenuse is... Okay, but if you want to write out hypotenuse equals short leg times 2, so 9 times 2 equals 18, that does not hurt my feelings, but you didn't know it off the top of your head. Alex is trying to get some points out of me. He's going to show me stuff like that. Go ahead.
You said that it's wrong to cancel out the square root of 3.
No, that's good. Good job. What I'm saying, Trey, is that you need to be prepared for a problem that looks very similar to this. It says x and y, and then there's a 30, but instead of being 9 square roots of 3, it ends up being just 9. So you have to do 9 divided by the square root of 3, and then you actually have to rationalize that denominator. There's potential for that with 30, 60, 90s as well. You end up getting 9 square roots of 3 over the square root of 9. So that's 9 square roots of 3 over 3, which is just 3 square roots of 3 for the short leg. And then the hypotenuse is double that, so it'd be 6 square roots of 3. Don't look at me like I'm crazy, Trey. Don't look at me like I'm crazy, Dave, for the test. Don't look at me like that. Don't look at me like that. Okay, here are my words if you're feeling a little crazy like Trey is. If you've not turned in your special right triangle stuff, it's late. I need it. The one that had you know what it looks like. I need, for instance, I see Nick's coloring page inside his sleeve. Did I give it back to him, or had Nick never turned it in? I need his coloring page and then his maze, not the maze I did with you. I don't need something I did back to me. I need the other one. It had homework problems on the front and the other little, it was like a, I don't even know what it said on the back. Don't look at me like I'm crazy.
Isn't something we had like
The actual maze.
I do not need this. I do not need that. I do need this one. It says 45, 45, 90, 30, 60, 90 problems at the bottom. I have a ton to pass back, but if you not turn that in, it's late to me and I need it. You want to give it to me, honestly, as soon as you can by the end of the day, because I don't promise to come back and pick it up, and that zero's going to be in there until Monday. Oh, that's a lie, because I'm going to come pick up your test, because I'm not letting this sit there all weekend. Okay. Nick has this useful 45, 45, 90, 30, 60, 90 thing. Am I going to... He did not make his 30, 60, 90 side useful. Should he use this? Oh, he has a second one. Okay, but let's go with me. Should he use his on the test? No, it's not worth the 5 points for him to lose, because it's not beautiful. But if yours is beautiful, and you're not feeling so confident, you can use this on the test. If you've not used the blue sheet on any of the checkpoints, Do not use the blue sheet on the test. You really don't need it, do you?
Yes.
You can if you want to. Okay, you use the blue sheet. But no. Okay. Am I going to be here tomorrow? So,
No.
no. So, I'm sorry, but we got to be honest. Nick is going to staple this to his test, so I know to take 5 points away from Nick. If I find out Nick used this and he doesn't staple it to his test, I get to take off more than just 5 points. So if you use your blue sheet, you need to staple it to your test. I'm that good. I have the spies and everything.
What are you doing?
I'm that good. So if you do not staple your blue sheet to your test and I find out and you use it, I'm taking off a whole lot more than just 5 points.
Are you taking the rest of the 95?
Yeah, for something like that. Something like that.
I don't want all these 5 points, but I need my food.
Oh, there was a giant bonus for this test, wasn't there? The giant pyramid things.
Oh, wait, when is that?
When is that due?
Tomorrow.
Why would it be due tomorrow, Nick?
Because that's when the test.
Because that's when the test is. Thank you, Nick. You're a genius. You didn't get the bonus pyramid? Okay. Nick also needs to turn in to me tomorrow the blue sheet he got yesterday. I know it spells out James Garfield because I know that's a picture of James Garfield. Is that what I need to see? That's all I need to see down at the bottom? James A. Garfield? No, I need to see you did some sort of math somewhere on Earth, not just get James A. Garfield. And I know the back is just as easy with the spell out thing. I need to see that Trey did some sort of math so I can give Trey some sort of points. If you got everything else in your life done, that's what I'd be working on. If you have a question for me, you need to ask it. I think I had some who weren't done with their, whatever you call it. I'm going to look to see so we can get you done.